right, just to officially define the two, the definition of displacement we have talked about previously in this class, but the definition of displacement is simply the integral of the volume over any given time interval. That's it. Okay, displacement is you take, so we're going to use integrals to find displacement. Just like we use integrals to find length of curve, integrals to find surface area, integrals to find volume, we can use integrals to find displacement. So displacement is just defined as the integral. The total distance, the only difference between that and displacement is that it's the absolute value of the velocity, because total distance accounts for all of the steps you do forward and backward. All right, so when Catherine runs her 400 hurdles, okay, her displacement is 0 because she makes one complete loop around the track, but her total distance is 400 because she's completed the whole thing. All right, so absolute value, regardless of direction. Okay, so as long as you keep that straight, that's really just going to get tested like on a multiple choice question. They'll give you one of the options will be with and one will be without, and hopefully you get the right thing. Okay, so 2 examples, one without a calculator, one with a calculator. All right, so compare net versus total distance for the following velocity for v of t being equal to 4 cos 2t on the interval 0 to pi. Okay, net is the same as displacement. Okay, those vocab words mean the same thing. So this would just be an easy thing to do without your calculator. So net, you're going to set up the integral from 0 to pi. Net would be the 4 cos 2t without needing your absolute value. And if I didn't have a calculator, I would think about what the graph looked like for 4 cos 2t, which looks like this. The integral of that and if I'm just going to pi, pi is the end right here. And so if I know what the picture of 4 cos 2t looks like, and I know what the period of 4 cos 2t is just pi, then I know just by area that the answer to this is 0. And I don't have to do any integration at all. So sometimes it helps to think visually about it to save you the work of doing the antiderivative. If I'm going to do total, I'm going to need to think about this thing maybe a little differently. Total means the negative area is not going to cancel each other out. And so if I'm thinking about the absolute value of 4 cos 2t dt, and I think about visually what that would do, that's going to look like this. Okay, there's the graph of the absolute value. It's just going to take the negative piece and make it a positive piece. So then how do I solve that? How can I take the absolute values off and come up with an answer? Yeah, I probably would. Okay, and I would use symmetry to my advantage. Okay, I know that this is pi fourths. This is 3 pi fourths. And so then pi halves has to be here. So using symmetry, I could maybe recognize, maybe I should just do this part. Because 0 to pi fourths is going to be the same as 3/4 to pi, that those two are going to be the same in size. And then what about the center section? It's double that, so what would be maybe the fastest way to do this? Okay, yeah, to do 4 times the first section only. So 4 times the integral that only goes from 0 to pi fourths. And then I can take the absolute values away. So usually when you don't have a calculator, there's a way to do it simpler so that you don't have to break this all up. So I'd pull the 16 out to the front, and then I would do the antiderivative of cosine, which is sine 2t, divided by 2 for the chain rule, plus c going from 0 to pi fourths. So that would be 8, 16 divided by 2, of the sine of 2t plus c, again going from 0 to pi fourths. So 8 sine, plugging in pi fourths, that would be 8 times sine of pi halves, minus 8 times sine of 0, which is 8. All right, any questions on that? Yes. If you're going to do it by hand. If you have your calculator, you can type the absolute value into your calculator inside the integral, not outside. If you do it outside the integral, then you would get the absolute value of, it would do the integral first, which is 0, and then it would tell you the answer is 0 again. So the absolute value would always have to go inside. If you're doing it by hand, you have to get rid of it. Now, if you didn't have symmetry to your, so if you had a graph maybe that looked like, you know, and it wasn't symmetric, okay, then you would have to break up, and so then the absolute value would make this piece go like this. Then you would have to do a separate integral going from 0 to the intersection point A, and then another separate one going from A to B. Okay? But usually there is something, what?
Like to make it positive, would you like if you minus that, or?
Mm-hmm. Yeah. Minus, put a minus in front of it.
Or you do plus, and then
Yes. Mm-hmm. Okay, next one you're going to need your calculator for, because the values are decimal values. Okay, so let's think about this. You can enter that into your calculator. V of t being the function t squared minus 8 over t plus 2 quantity squared. So that's the volume, and time is always going to be positive. Okay, a couple questions about this. If that's the volume, if that's the velocity, when will the object return to its starting position? Okay, or initial position. You don't even need to know what the initial position is. You just need to know when it will get there. Okay? When will the object return to its initial position? Which is really code for asking when is the displacement 0? It's the same question. Okay, so when is displacement equal to 0? All right, so we're going to use our calculator to do that. This is the way you're going to use that. The displacement, starting with time 0, going to an unknown time of x, which we don't know, of the t squared minus 8 over t plus 2 quantity squared dt. And we would like to set that equal to 0. So we're going to do that graphically. We are going to have the calculator graph the integral, do a math 9, and then we're going to look for when that graph first crosses 0, which will tell me when this thing has a displacement value of 0. All right, so let's try that on our calculator.
It says you have 50 factor